This video is part of the lecture for multivariable calculus, and I'm gonna talk about some examples of the chain rule for a function of two or more variables. So let me start by example 1. Let w to be e to the power of xy squared, where x is equal to 3t plus 1 and y equals to t squared. Find dw dt. Okay, as I explained on the video for the chain rule, I said that whenever you have a function, try to graph a tree of the variables to see how to take derivative. So w is a function of x and y, and actually, and x is a function of t, y is a function of t. So since w is a function of two variables, I need to have partials in here, and then in here I need to have just the simple derivative. So I have dw dt. I can go along this path to go to t, so it would be partial of w with respect to x times derivative of x with respect to t, okay, plus I can go along this path, which is partial of w with respect to y, and then dy dt. Okay, so partial of w with respect to x, it would be what? E to the power of x y squared, derivative of the inside function, derivative of that with respect to x. Y is a constant, so I get y squared. Then derivative of x with respect to t is just 3. Derivative of w with respect to y, so actually I forgot to give you a recall of, if you have e to the u, e to power of any function, derivative of that would be derivative of the function e to the u. Okay, so derivative of w with respect to y, it would be the exponential function itself, e to the xy squared, and then derivative of x y squared with respect to y would be just 2xy. Derivative of y with respect to t is just 2t. Okay, now you can replace any x and y with the given functions, and then you have everything in terms of t. Example 2. Example 2 is very interesting because it's actually application of the chain rule. Application. And it's very kind of a well-known application. It's product rule and quotient rule. So product rule and quotient rule. So it's application of the chain rule, but how? Let's see. If we have a function f of u and v, let's say this is your w, and then let u to be a function of t and v is a function of t. Okay, so basically I have these three. W, which is f, is a function of u and v, u is a function of t, v is a function of t. So I have partials in here because f or w is a function of just two variables, and then I have d in here. Okay, now df dt, okay, df dt, because f at the end of the day is a function of just one variable t. Okay, so that's why I have df dt. Okay, so it would be what? It would be partial of f with respect to u, and then du dt plus partial f with respect to v dv dt. Okay, so now this is the general case, but let f to be equal to uv, the product of u and v. Okay, in that case I have what? I have derivative of f with respect to u is just v, derivative of u with respect to t, I'm just gonna write this, plus derivative of f with respect to v, derivative of f with respect to v is just u, times derivative of v with respect to t, I'm just gonna write this. As you see, this is the product rule. The uv derivative would be derivative of the first one times the second one plus derivative of the second one times the first one. That's product rule. Okay, now let's say that I have this situation. Let f to be u over v. Okay, so if we have u divided by v, then derivative of that would be what? The partial of f with respect to u. With respect to u, v is just a constant. Say I have u over 5, for example. Derivative of that would be 1 over 5, 1 over v, times derivative of u over t, so du dt, plus derivative of f with respect to v. With respect to v is just a constant. For example, I have 5 over v. Derivative of that, it would be v squared negative 5, right? So it is negative. 5 was just my u over v squared, and then dv dt. Good. So let me simplify that. I'm gonna take the common denominator between these two, and the common denominator would be v squared. So I have v squared. Then I have what? I have v squared. So that's why I need to multiply by v. So I get v du dt, right? And then I have a negative u, and then dv dt. Isn't it quotient rule? Let me bring this one down. So this is basically derivative of u divided by v. You see, derivative of that would be denominator square, derivative of the numerator times denominator minus derivative of the denominator times the numerator. So that's the quotient rule. Quotient rule. Okay, so as you see, we were able to find product rule and quotient rule using the chain rule of a function of two variables. Okay, let's look at another example. Example 3. Let g of s and t to be f of s squared minus t squared and t squared minus s squared, and f is differentiable. Show that t times derivative of g with respect to s plus s times derivative of g with respect to t is equal to 0. Okay, so to solve that, first let me have my graph. I'm gonna call this one x, I'm gonna call this one y, and I have a function g, which is basically f. G or f is a function of x and y, x is a function of s and t, y is a function of s and t. Okay, I'm gonna find derivative of g with respect to s. So with respect to x, I can go along this path, or I can go along this path. Okay, so I get what? Derivative of g with respect to s, I'm not gonna write the formula, I'm just start calculating that. Partial derivative of g with respect to x would be fx, right? And then derivative of x with respect to s. Derivative of x with respect to s, it would be just 2s, plus derivative of f or g with respect to y would be fy, and then derivative of y with respect to s. With respect to s, it is negative 2s. Okay, I have derivative of g with respect to t in the formula that I need to prove, so I'm gonna calculate that. Okay, to calculate this, I can go along, let me remove this path and replace it with the new ones. Okay, with respect to t, I can go along this path, or I can go along this path. Okay, so it would be derivative of f with respect to x, derivative of x with respect to t, negative 2t, plus derivative of f with respect to y, derivative of y with respect to t, it's just 2t. Okay, now let's calculate t derivative of g with respect to s plus s derivative of g with respect to t. Okay, I'm gonna multiply t by here, so I get 2st fx plus actually negative 2st fy, and I'm gonna multiply this term in here by s, so I get negative 2ts fx plus 2ts fy. Okay, so as you see, fy in here and fy in here, these two would be cancelled, and then 2sx st fx, and then this one would be cancelled, so I get a 0.